explain here another example how to find the domain of a function, in the case of roots with factors inside. And now here, first you may notice here inside the root we have a division here. You may feel something wrong here because these aren't factors, they're not multiplying. But okay, we could say that we could discuss that further in some other video or maybe later if these are factors or not indeed. So I'm just going to start right away how to solve this out. In the beginning, and I think you will notice on the way that it's very similar to what we have done before. So I'm going to start by taking what's inside the root here, be the x minus 5 over x plus 3, and set it greater or equal than 0. Now this thing we have here, it's something called a rational inequality, and the way to solve this out is actually very similar to what we have done before. We have to pick what's in the denominator and what's in the denominator, and we equalize them to 0 just independently. We do it like this: x minus 0, it's equal, x minus 5 equal to 0, and x plus 3 equal to 0. Now we solve them out. We x equal to 5 here, and here x equal to -3, like this. I'm just going to place these two values on the graph on the right. -3 here and 5 here. I guess you've been noticing we are doing something very similar to what we have done before. And from here on, I'm actually doing pretty much the same thing. I'm going to pick values for each interval here. I'm going to pick here x equal to, I don't know, let's say -10. And here I'm going to pick x equal to 0. And here I'm going to pick x equal to 10, positive 10. Now what I'm going to do is I'm going to substitute each of these three values for x in here in the rational expression. So it will be here, I will have the -10 minus 5 over -10 plus 3 and greater or equal than 0. We solve this out and we get this -15 over -7 greater or equal than 0. And here again we have just to be concerned actually with the signs here. It will be a negative over a negative. This is better. Negative over negative, is greater or equal than 0. And we have to ask, is this greater or equal than 0? Well, if you divide a negative over a negative, you will get actually a positive number. So this is telling us that this passes the greater or equal test. So, and then we just color out here on our graph, on our line here, like this. Now we have to repeat the process again for the x equal to 0. It will be 0 minus 5 over 0 plus 3. I'm just substituting the value of x equal to 0 here in the rational inequality. And this has to be greater or equal than 0. Then we get this -5 over positive 3, greater or equal than 0. Again, we have just to be concerned with the signs. It will be a negative over a positive, greater or equal than 0. And we have to ask ourselves again if this passes the test of this greater or equal than 0. Well, you divide a negative over a positive, you will get a negative number. That is to say that you will get a negative number here inside the root, and so we cannot include this interval here. We do not include it. Now I'm going to do the same with the last value of x here, x equal to 10. I'm going to substitute it again here in this rational inequality. Here will be a 10 minus 5 over 10 plus 3. Is this greater or equal than 0? We get to the solution here. It will be 5 over 13. Is this greater or equal than 0? Now we have again just to pay attention to the signs. Here will be a positive over a positive. And we have to ask, is this greater or equal than 0? Well, yes, of course it will. this will be always greater or equal than 0, a positive number at the end. So we include this interval here. Now, here there comes a thing. We have to also as well test these two values, because there is a very small difference with the previous examples that we have done here. So I'm going to start by substituting the 5 in the rational inequality. So we get here a 5 minus 5 over 5 plus 3. It is greater or equal than 0. And we get to a 0 over 8 here. And we have to ask, is this greater or equal than 0? Well, actually it is equal to 0. We get to this one here. And so this is okay. It passes the test because equal to 0 will fall into the equal part of this inequality. And as this falls into this, has no problem with this expression here, they're saying we have to include the 5 in the solution. So we include it by signing it like this. We color out this circle here and the 5 here. Now I'm going to do the same with the negative 3. I'm going to substitute the negative 3 in the rational inequality, and I'll get to something like this: negative 3 minus 5 over negative 3 plus 3 greater or equal than 0. And then I will get to this: negative 8 over 0 greater or equal than 0. Now this have to ask, is this greater or equal than 0? No, it's not. This is not. This is an undefined in mathematics, so we cannot include it in the domain. So if we do not include it, we have to sign it like here, a non-colored circle, a non-colored circle here. And that is saying to us that we do not include the negative 3 in the domain of this function here. Now that we have all the information we required, I'm just going to write the domain here down on the left here. Domain of f will be from negative infinite until negative 3. We do not include the 3, and then we use a parenthesis here. We do not include the 3, and we'll get union 5. It's too ugly. 5, we use a bracket here because we are including the 5. We're including the 5 here, and till infinite. By just doing so, that would be all of it.